Hi everybody, welcome to week 8, lesson 1 for year 6 maths. Today we're looking at parts of a circle. So our main learning intention today is to identify parts of a circle. So to do that, you'll need to firstly identify and name the different parts of a circle, understand the relationship between those different parts, and lastly what we're going to do is draw a circle using a fixed center point and a compass. But let's look at parts of a circle. So we've got a nice circle drawn here. The most obvious part of a circle is probably going to be its center point, right in the middle. So that's our center of the circle. Then on the outside, the line or the edge of the circle is its perimeter, but it goes by the name of a circumference. So circum means around, so it's going all the way around. It's a circumference. The next most important part of a circle is its radius. So the radius is the distance between the center and the circumference. And the radius doesn't just have to be here, it can be any point on the circle, it can be down here, it can be down here, and so on. And one thing you'll notice is that the radius going all the way around, the length of the radius will always stay the same because it's equidistant, that is the same distance from the center point and the circumference. So it's always going to be the same length all the way around. Then we have the diameter. So the diameter is a line that is cut through the center from one side of the circumference of the circle to the other. So it's always straight and it always passes through the center. So the diameter, in effect, we can also have a diameter, going this way and so on. So there's already a relationship there. We can see that the diameter, in essence, is twice the length of the radius. The diameter will always be the same, regardless of where it is on the circle. If it's vertical or diagonal or horizontal, it will always be the same. Just like the radius. The radius will always have the same distance or length between the center point and the circumference. Now let's divide our circle in half. We get a semicircle. So you've heard that before, nice and simple. It's half of a circle. As again, it can be anywhere. It could be vertical, horizontal. It's the area of half a circle. Then we have a quadrant, which it comes from quad meaning 4. It's like a quarter. It's a quarter of a circle. It's a quadrant. Again, it can be anywhere on the circle. And then lastly, we have the sector. So a sector is an area of a circle, starting from the center point in the middle here, and we've got one radius on one side and a radius on the other, and it's smaller than a quadrant. So you can see the relationship between these different lines and the center point and the circumference. For our quadrant, we have the center point. We've got two radii, which is radiuses. And for our semicircle, we use a diameter to create the semicircle. And that's the parts of a circle. So now let's look at drawing a circle. So here I've got my center point, and I know that my radius is always the same distance from the center point to the circumference, which is the edge of the circle. So what I can do is I can measure a distance and draw a radius to a point. Then I can do that in another direction, making sure that the distance is the same for the radius to another point. I can keep on doing that. So I've got lots of points. And then now all I need to do, because I know this radius connects the circumference with the center, I just need to connect these dots, and there you go, I have a circle. So normally if we were at face-to-face learning and we were at school, we'd be learning to use these metal maths compasses or geometry compasses. Unfortunately, we are not. I don't expect you to have one of these at home. So what I've done today is I've included some instructions in your activities, which have instructions on how to make your own homemade compass. But I thought I'd show you this video anyway, where this lady explains how to use a metal geometry compass and some of the things you'll need to take into consideration when you're using your homemade compass are in this video. One of the tricks she does in terms of turning the paper, you probably won't be able to do with the instructions I gave you, but it's really important that you keep the radius, that is the distance between the center and the circumference, always at the same constant distance.
This is a demonstration on how to use a compass. This is a compass, and it is a mathematical tool that is used for drawing circles. What you're going to need is a pencil that has a sharp point. So don't put a pencil in that has a blunt point, because then you'd have to take it apart to sharpen it. What we're going to do, you twist this open. You see the opening there? That is where you're going to push your pencil into. But before you tighten it, you make sure that the pencil point and the point of the compass are at equal length to each other there, so you can see there. And just as you get that, then tighten that screw so that the pencil does not move. Now when you open up the compass, that is the radius, which means that that is the half size of a circle that you're going to draw. The wider you open it, the larger the radius, which means the larger the circle. Now I'm going to demonstrate how to use this. You've got a handle there, but for those of you that are very new to using the compass, I'm going to show you an easy trick. So find where you want to do, how wide you want your circle and where you want to draw your circle. And this is how I would draw mine. And I put pressure, I'm holding the handle at the top, but I'm putting pressure on the point and I'm turning the pencil around. But for those of you that are new to this, I would hold the point, the handle or the point down and bring my pencil around, and actually by just holding the point down I can just turn my paper, and there I have drawn two circles. Do not hold the compass by both legs, because if you do, what happens is it starts to close and then you're going to get an uneven circle. So always hold the leg that has the point or the handle part there. You do not need to hold this part. And if I just demonstrate one more time, for those of you that are new to this, hold your point leg and turn your paper. This is a demonstration on how to use a compass. This is a compass, and it is a mathematical tool that is used for drawing circles. What you're going to need is a pencil that has a sharp point. So don't put a pencil in that has a blunt
Okay, and that's the end of today's lesson. So some of the main ideas, parts of a circle have specific names or vocabulary attached to them. So we know that we've got the center, perimeter, or the line on the outside, the edge of the circle, the curved edge is the circumference. We've got the radius, which is the distance between the center and the circumference, and the diameter, which is basically from one side of the circumference to the other, passing through the center. The radius is always starts at the center point here and moves out to the circumference. So whichever way it's going, always starts at the center. Just like the diameter, it has to pass through the center. It has to go from one side of the circumference to the other, to the opposite side. And it's a straight line as well. I should mention that. The radius is half the length of the diameter, and conversely, the diameter is twice the length of the radius. That's the real important relationship you need to remember today, particularly for your activities. And lastly, we can draw a circle by making equidistant points. That means that they're equal distance from the center, and then just connecting them around here to make the circumference. Now that's essentially what a compass does. It makes sure that the pencil on the outside is always kept at the same distance as the point in the middle as you turn the pencil around. That's basically uses the same principle. All right, guys, I'll see you for tomorrow's lessons. Have a great day. Hi, everyone. Welcome to Week 8, Lesson 2 for Tuesday, Year 6 Maths. Today, we're looking at transformations. So today, we're learning to identify different transformations that 2D shapes have undergone. So this is actually a part of transformational geometry and looking at how 2D shapes change when they're transformed. So we're learning to identify if a shape has been either translated, reflected, or rotated. They're the three different transformations we're looking at today. We're identifying whether it's undergone more than one transformation. So it might have undergone a combination of these, translation, reflection, or rotation, and then using words to describe the transformation. Okay, the first transformation we're going to look at is translation. Now, you might remember this from previous years called a slide. This is where we are moving the shape to a different position by sliding it. So, for example, we can do that horizontally. And to describe that transformation, I would say that it's been translated horizontally. I can also do it vertically. And I'd say that's been translated vertically. So I'm using that directional language. I'm not just saying, oh, it's been translated. I'm saying in what direction it's been translated. And also I can translate it diagonally. And there again, I've written the direction there. So not just translated, but translated diagonally. So that's really important today when you're doing your activities, that you are specific about the transformation, but also the detail around it. What position, what direction has it been translated in? What direction has it been reflected, and so on. Now we're going to look at reflection. Now this is also known as a flip as well. And it's where we have a line of reflection, so very similar to symmetry. And we reflect the shape over the line. So we'll flip it over the line. So here I've got this L shape or backwards L shape, and I'm going to reflect it over this line. And because it's horizontal, it's still horizontal to that original green shape, I'm going to say it's reflected horizontally. Now I've used a different color here to distinguish it from the original one, and you might see that in some of your activities today. I can also reflect it over this line. So I draw a line underneath the shape itself, or an imaginary line, and reflect it, and it's been reflected vertically. Now, horizontally and vertically, we can also do it diagonally as well. So I could give it a line of reflection here and reflect it diagonally like that, or also another line of reflection here and there, or I could also draw some here as well and reflect them over either of those lines. I'm sort of running out of room. And in that case, I'd say it's been reflected diagonally. Now, here I'm going to do a rotation, which is the last transformation we're looking at today, and this is just a turn. But unlike the translation and the reflection, I can't use horizontally or vertically or diagonally to describe a turn. So I have to use two different pieces of information. Firstly is the direction. So I'm going to use clockwise and anti-clockwise. So today I'm going to be turning it clockwise in the direction that a clock or the clock hands go. And then also I'm going to use my knowledge of degrees. So I know that within a full circle, I have 360 degrees. And each time it turns a quarter circle, that's 360 divided by 4, it's going to be 90 degrees. So for this one, I'm going to turn it or rotate it 90 degrees clockwise. And so I'd say it's been rotated 90 degrees clockwise. I can rotate it another 90 degrees. I'd say that's rotated 180 degrees clockwise. And I can also say it's been rotated 270 degrees clockwise, or I could also say it's been rotated 90 degrees anti-clockwise as well, if I'd gone in that direction. And then it's back to its starting position. You could arguably say it's been rotated 360 degrees clockwise or 360 degrees anti-clockwise. We don't really know because it's a static image. That's what you'll get today. You won't actually see the animation of it moving, but you could argue that as well. Okay, so now let's look at some transformations. Now these are one-step transformations, so there's only one transformation involved. That's either reflection, rotation, or translation. And these are the type you'll see in your activities today, where you'll have a shape on the left, and then it's been translated or reflected or rotated to the shape on the right. So you'll need to visualize it. You won't have the luxury of seeing the shape animate in front of your eyes. With this case of the triangle, I can see that if I drew a line of reflection down the middle, that I could reflect this triangle on the left and end up with the triangle on the right as a mirror image, a reflected image of the triangle on the left. And I've done it horizontally, so I'd say that it's been reflected horizontally. With these pentagons, these two pentagons, I look at the one on the left again, and I could say that it's been translated or slid horizontally. Alternatively, I could also say that it's been reflected horizontally. If I drew the same line of reflection, now there is a gap here, but that doesn't matter. I can still draw it down the middle, and assuming that there's equal space on each side, then I could say that it's been reflected horizontally as well, because it's a symmetrical shape, and the reflection is going to look the same in this case. And lastly, I've got these arrows. Now, I know that reflecting is not going to help because the point is facing down this way. And I also know that I can't just slide it or translate it into that position because it's always going to be pointing in this direction, regardless of where I slide it. So it's going to need to be a rotation. And I also have to remember when I'm talking about the rotation to describe the direction and how many degrees. So I've said it's been rotated 90 degrees clockwise. And the last thing we're going to look at is these multiple step transformations. So this is where you might have a bit of a space between the two shapes, the original shape and then the shape you've arrived at. Now here I could just say that this shape has been translated horizontally to the right because it hasn't actually changed the angle or anything else, it's just moved. I could also argue that it's been reflected twice. So if I drew a line of reflection here, and then I'd end up with the mirror image of it. So it would look like this. And then it's been reflected again and end up with the original image like that. So that's one way of thinking about it. So often these problems have more than one way of describing the transformation as long as it works. Here we've got a trapezoid that's upside down, or trapezium, I should say. I could say that it's been translated vertically, then translated horizontally, and then rotated 90 degrees anti-clockwise. Also, I could just say that it's been translated diagonally and then rotated 90 degrees anti-clockwise. Otherwise, I could say that it has been reflected or flipped vertically, then it's been translated, and then it's been rotated 90 degrees clockwise instead. So multiple steps for that one. And that's our lesson for today. So the main idea, we have these three transformations, how we can transform shapes. We've got translation, which is sliding, reflection, which is flipping or reflecting on a line of reflection, and rotation, which is turning. Make sure when you are describing the transformation that a shape has undergone that you are specific. So you use directional language, whether it's horizontal or vertical, or in the case of rotations, you're talking about clockwise and anti-clockwise, as well as the number of degrees. So for example, rotated 180 degrees clockwise. And lastly, multiple step transformations can be perceived differently, so they can have multiple solutions that work. As long as, if you provided the steps for that translation, as long as the steps work, then that's totally fine. All right, I'll see you tomorrow where we're looking at transformation patterns. Okay, now I'm going to show you how to make patterns in Google Docs. So in your work for today, you'll have these drawings. You just need to double click them and it'll bring you into drawing. Then all you need to do is select the shape. So for this one, it's asking me to reflect it. So I can right click it, then I can go to rotate. Now what's going to happen is if I choose flip horizontally, it's just going to flip the shape like that. So I don't want that. What I want to do is I want to select the shape, go Control C to make a copy, and then Control V. Now I've got a second shape, so I can move it into position here. And what I'm going to do, I know this isn't the normal flip because you'd flip over this line, but all I need to do is go flip horizontally, and there you go. I can also rotate the shape like this if I need to. It actually even has rotate 90 degrees counterclockwise, 90 degrees clockwise, if that's what you need to do. And obviously, as you keep going along, just go Control C to copy, Control V to paste, and so on. And then you're going to continue making the pattern as you go along. So you can see here, I've made a pattern with this heart shape, and the pattern is rotate 90 degrees anti-clockwise each time. So each time I put in the heart, and it's been rotated 90 degrees anti-clockwise. So here, from this position, and then another 90 degrees, and another 90 degrees, and it's back to 360, and then I keep on going. Now I've only done the top line, I haven't done the bottom line. Some of your patterns might require you to do the bottom line if it's a vertical reflection or a translation. But if it's just this, like 90 degrees anti-clockwise, I haven't done it down the bottom because someone might confuse, oh, is this like a reflection or a rotation or a translation down? So I've only really done the top row. And that's it for today's lesson. It's really very simple today. It's not too complex. So in your Google Doc, to create the transformation pattern, double click on the drawing, Control C, so hold down Control and C to copy the shape, and then Control V to paste the shape. Right click on it and then select rotate, and you can either select flip horizontally or flip vertically if that's what you need to do. Otherwise, you can drag the corners to turn the shape. You can't do that to flip it, but you know that if you do a rotation, you can make it look like it's been flipped. Use right click, rotate, and you can either do a 90 degrees clockwise rotation or a 90 degrees counterclockwise rotation. Please make sure that you do this in the Google Doc today. It's really important that you do this using software. That's a part of what we need to cover today. So don't draw this on some paper. Use the Google Doc. I'd like to see it. I'd like to see you use the Google Doc to manipulate the shapes. Okay, guys, that's all for today. It won't take you too long, and I'll see you tomorrow for Thursday's lesson, which is the last video lesson of the week. Hi there, welcome to week 8, lesson 4 for Thursday, year 6 maths. Today we are looking at predicting transformations. This will be a nice quick lesson today. So today we're learning to predict the next transformation in a pattern. So a shape pattern made up of 2D shapes and finding out what the next transformation in that pattern is going to be. So to do this, you'll need to recognize the different transformations we've been looking at this week: reflection, rotation, and translation. Then identify a pattern based on those transformations, and then use words to describe the pattern, and also identify a pattern from a list of options. So now I'm just going to work through some examples like the ones you'll see in your work today. So here we've got a pattern with a like a little Pac-Man figure, and I can see with this pattern that it's going from left to right. So all your patterns will go from left to right, and it seems to be rotating 90 degrees clockwise. So in this direction, you could argue that it's been rotated 270 degrees counterclockwise, but I'm just going to make it nice and simple, go for the shortest one. And then here, this image is the same as this one, the shape is the same one, so I think it's been just translated. Then again, I think it's been rotated 90 degrees clockwise, then translated 90 degrees clockwise. So I think I've figured out a pattern. The pattern is rotate 90 degrees clockwise, then translate horizontally. So I'm using that language there, that directional language, horizontally. Because I know this pattern goes from left to right, I'm not going to say translate horizontally to the right. You could if you really want to, but it's unnecessary. And so the next shape in this pattern, the transformation it's going to undergo, well, I've done the rotate 90 degrees clockwise just here between these two. So the next one is going to be a horizontal translation, and it'll look exactly the same as the shape before it, just in a different position. Here we've got a pattern which is a little bit more complex. So I'm starting with this one here in the top left-hand corner. I'm going to read it from left to right. So there's no shape in this position here, but I can see one underneath. So what I think has happened here is it's been reflected vertically. And then I can see I've got a mirror image of this shape here. So it's been reflected horizontally. And again, another mirror image reflected horizontally. Now again, I have a space here, but I can see I've got this shape above. So I think it's been reflected vertically. Then reflected horizontally, then reflected vertically. So I wonder what the next transformation is going to be in this pattern. Well, I think it's reflect vertically, reflect horizontally, reflect horizontally, reflect vertically, reflect horizontally, reflect horizontally. And there's my pattern. So the next shape in this pattern, the transformation it's going to undergo, will be a horizontal reflection up here. And so I've written reflect horizontally. Now, the second last thing you're going to do today is look at a pattern and then describe, or find the best description, I should say, that describes the transformation of the shape in that pattern. So here we've got choose the option that best describes the transformations, and I've got multiple choice, so A to D. So this shape could have been rotated. Well, that's true. It could have been rotated 180 degrees. So that one's a possibility. It could have been reflected as well, because I can draw a line of reflection here, and it could have reflected it over this way to form a mirror image or a reflected image. I don't think it could have been translated just neatly like that, because it still needs to either be rotated or reflected. A translation, it would still look the same as it did in the first position. So I'm going to scratch that one out. And because it can't be translated, I can also scratch that one out. So these two options are a possibility, but I want the one that best describes it. So reflected or rotated, we saw that it could do both. So the best option is B here. So over this side, we've got some squares, and we want to choose the option that best describes the transformation or transformations that have happened in here. Now, it might have had different types of transformations that are still possible. I've just put or here. I didn't do and or. I'm not going to be that particular, but just so you know. So this shape could have been rotated as A. Well, it could have been rotated because it could go 90 degrees or 180 degrees or 270 degrees or 360 degrees and still look like the shape in the first position. So that's a possibility. It could also have been reflected because I can draw my line of reflection here. If I reflect it over this way, it's still going to look like the square in the first position. That's also a possibility. It could be translated because we know when we translate a shape, it doesn't actually change any of its the way where the vertexes are pointing or whether it's sort of on a diagonal. It basically is just moving the shape to another position, sliding it along. So that's a possibility, translated. And then translated or reflected, or we saw that we could do that for both. But C is the best option here because it can be translated, rotated, and or reflected throughout this pattern here. So they are all options. So that's my best description for this particular pattern. Okay, the last activity today is not actually related to replicating a pattern and continuing a pattern as such. It's to do with this idea of rotational symmetry. So year 5 this week, they've been looking at different types of symmetry, and I thought it might be a nice idea for you guys to finish on something where it's not so tedious as continuing a pattern, but actually kind of creating a nice artwork. So we know that reflective symmetry is where we have a shape like this triangle, for example, and I draw a line or an axis of symmetry down the middle. And if I imagine this was a piece of paper, cut out a piece of paper of a triangle, and I flip this over, this side of the triangle, now it's flipped over, would be completely congruent with this side of the triangle. So there wouldn't be any paper overhanging, or it wouldn't be too small. It'd be the exact same size and same position. So with rotational symmetry, the idea is when you rotate a shape, how many times within 360-degree rotation will the shape look the same as the starting position? Now here, the shape obviously is a circle, so it's not going to change. It's going to basically have infinite amount of rotational symmetry, but it's more to do with the pattern on the inside. So it's been divided into eighths, and within each of those eighths, we've got the same pattern. So each time, imagining if this eighth here moved into this position, the pattern would be the same, and so on. So just a nice, relaxing art activity to finish off the week. I hope you enjoyed this week on transformations, and I'll see you next week for our unit on chance. Bye-bye.